Hi there, this is our third look at transformations for exercise 3A. We've only gone on to the third lesson video because there's some exam questions which we haven't yet looked at. So if we have a look at these now, hopefully these will make a bit of sense. It's always good to see what the exam questions look like, so that's what this is all about. Hopefully you've remembered what we've done so far. So June 2011 this came from, so it's quite an old question, but it's just another chance for you to see kind of things that you're meant to be able to do. And it says the curve y equals log x is transformed by, now so it's got a reflection in the x-axis. There's then a stretch with a scale factor 3 parallel to the y-axis. So I do think it's worth getting your head around what order, what direction there are that do these do it. A reflection in the x-axis is an up and down transformation. It was up and now it's down, or vice versa. Followed by a stretch with a scale factor of 3 parallel to the y-axis. This is also up and down. And followed by a translation in the positive y. Alright, this is y direction as well. This is a translation up and down. So all three of these things are up and down. So we've got to be just be careful of what order we do it in. Now you may recall that I said when we get an equation of this form, y equals, it was a f of f, and I had a bx plus c, something like this. So basically I was trying to show you that if you have two things inside the brackets, well, these two things you're going to, weirdly, you don't follow Bidmus or Bodmus, whatever you call it. You kind of do the adding first and then you do the times in, and that's because it's in brackets and therefore it's the wrong order. Now when we have things outside the bracket, so for instance it might be AF of x plus b, and we've got two transformations now and they're both outside the brackets. Well, now you do follow Bidmus. So on the first one I said Bidmus is a no. Here Bidmus is a yes. Because it's outside the bracket, we do what it says it should be. We do things in the right order. So it says here we've got a reflection. That's effectively like a times in by -1, followed by a stretch, scale factor of 3. So I think this is going to be y equals log of x initially. And to make it a reflection of the x-axis, I know it's got to be put a minus in front and stretch it scale factor 3 to the y-axis. I reckon that's it. I reckon I've already done that one and this one. The only slight issue is I've also got to do a translation in the positive y direction by log 4, which is, so I could go plus log 4, and you notice I'm just adding log 4 on. So that's actually the answer. But interestingly, it says find the equation of the resultant curve given your answer in the form, they just want log of something, y equals log of something, and mine isn't. Mine's y equals -3 log of x plus log of 4. So I've got to join these together somehow, and you'll remember the power law for this. This can be moved up there, so I'm going to say log of x to the -3 plus log of 4. So I've already made some progress. And the only other thing is it now says I've got a plus, and you may recall that if you have two logarithms added together, you can write this as y equals, and you can go log, and you can times them within the bracket. And that can also be written as, I should really written there. This implies that y equals log of 4 over x cubed. And now I've got log of something. Let's see what the answer says. There you go, that's what it says. Okay. Second question. Was it the last one, January 11? Oh, the last one was June 11. This is Jan 11, question 2. So in this paper, they've drawn a function for us. They didn't tell us what it is. That's quite a good way for them to make sure you don't just do it on the graphical calculator if you had one. The diagram shows the curve of y equals f of x. So this is my curve. This is y equals f of x. And it says it is given that -7, if you put that in, you get 0 out. And it's got two stationary points, one here at -2, -6, and one at 0, 0. Okay, we've got some information about that curve. Sketch the curve which has got this and this happening to it. Notice Interestingly, this helps me a lot. Actually, this is outside the bracket, so that's just going to go up and down. This has not got, say, 2x plus 3. It says x plus 3. So this is going to go minus 3 in that direction. So I actually think this is a relatively straightforward answer to this. I think it's going to be, if I was to draw it, it's going to go left 3. So all the x direction points of these I know will go, so that minus 7 now will be at minus 10. The minus 2 comma minus 6 will be at minus 2 comma got to go 3 left, so minus 5, sorry, comma minus 6. So I've gone, was at minus 2, it's now at minus 5. And this one, rather than be at 0, 0, is now going to be at minus 3, 0. So I've taken account of there in doing this. I don't, so it's going to, if that was it would look something like that. But of course it's not it, because I've got now times by a negative 4. And what that will do, the minus will flip it upside down. It will reflect it in the x-axis. But it will also stretch by a scale factor of 4 as well. So I can tell you now exactly what this looks like. I'm going to try my best to draw it as well. So the minus 10 is still at minus 10. But the minus 5, which is there, something like that, is now minus 5, and it's flipped up to the top, and it's times by 4, so comma 24. And the minus 3 naught, well, if I times that by 4, it's still naught, so and the flip doesn't make a difference. So these two stay where they are. But my graph now does this. And that's what my graph is. So sketch the curve, yes, and indicate the coordinates of the stationary points. I think I've done all of that. And let's see what it says. A graph showing reflection, yes, I've reflected it. The graph showing a translation, yes, I've moved 3 to the left. Draw more or less the correct graph, and minus 5, 24, yes, and minus 3, 0 stated. Boom. Thank you. The last one then is this one. It says that we've got this function f is defined for all real values of x by f of x equals kx squared plus 4x. Now, straight away I know x squared plus 4x can be factorized to x plus 4. And that means it will cross the x-axis at 0 and minus 4. And so presumably that's what this graph is doing. Now, the fact that I'm timesing by k, of course, just means it's a stretch upwards. It's a stretch upwards by some number I don't know. So anyway, let's have a look at the curve. Y equals x squared can be transformed to y equals f of x. So we can go from x squared to this by this sequence of transformations. Now, number 1, it says a translation. Well, you can see it's definitely being translated to the left. A translation parallel to the y-axis. So that's a translation downwards. Yes, all right, then I'll go with that. And then there's a stretch. Now, they are saying it's in this particular order, so I've got to be slightly careful. So the reason why I've got to be careful is because I think if I was doing it, I mean, this effectively has got two things going on at the same time. It's a y equals. There's a translation going on left. There's a translation down. So I want to write this as a, and you have to forgive me for a bit, f of x. There's a translation, so I'm going to write plus b in the bracket plus a c. And you can see there's three things. There's my stretch, there's that translation, and there's my final translation. That's what's happening. And yet they are forcing me to give it in this order. They're saying this translation to the x-axis first. So I will really just going to be a bit careful. I think it goes from there. By symmetry, that's at -2. I think it's going 2 left. It's a translation parallel to the y-axis. So it's up and down. and then there's a stretch. My final answer is kx squared. So if we just put this down, I think I'm right with this. So we've got a translation number one. Number one, I would say there's a translation by a scale factor. I think -2, 0. Number two, there's a translation. And I suppose this is the only tricky part of this. You've just got to be careful, because how far down has it gone? And I think if I'm going to do this, I want to complete the square. So I'll do it over here. So it says y equals x squared plus 4x in brackets. I'll ignore the k until the end. So if I rewrite that's x plus 2 all squared, and I've halved the 4, but of course then I've got to minus the 4, which is the square of 2. So that tells me this point up here on my graph normally would be -2, -4. And so this then is 0, -4. That's the thing that I was just struggling with a bit, just to get my head around what I had to do. And the last thing's easy enough. It's a stretch parallel to the y-axis scale factor of k. So the last thing it says, find the range. Of course, we've done functions recently. Find the range of f in terms of k. Well, the range is what number comes out of the graph. So all numbers above this point. So the temptation is here, and I say the temptation because I think it's slightly wrong. The range is y belongs to the real numbers. Y is bigger than some magic number down there, bigger than -4. Now I say it's wrong because it's actually not -4, because this is the graph before it is being stretched by k. So I think it's greater than or equal to actually -4k, and this is the times and by the stretch. So what have they got? Yes, that's what they've got. So we've eventually got there. So you've had 3 lesson videos now. I'm hoping you can now answer all the questions, but there's a variety of questions coming your way, and you've got to think on your feet a bit. Any problems though, do email me or Miss Frovine or Miss Stanley, and hopefully one of us will be able to answer you. So best of luck, and hope that goes well.